In this lesson, we're multiplying algebraic fractions. My definition of an algebraic fraction is a fraction that has at least one variable in it. I've seen another definition that specifically says that it's a fraction that has to have a variable in the denominator. But for either definition, the rules for multiplication are much the same as the rules for multiplying fractions that you probably learned several years ago when multiplying numerical fractions. We're looking for common factors in both the numerator and the denominator, and in this example, we start with the 3 and the 12. 3 goes into 12 4 times. 5 goes into 35 7 times. And then we have an a to the 5th on the numerator and an a to the 2nd in the other denominator, so they share the a to the 2nd, leaving an a cubed in our numerator. And for the b terms, we have a b and a b squared, so they have a common factor of b. And now we seem to have marked everything out that we can. We look to see what's left, and what's left is 7a cubed b in the numerator and 4 in the denominator. Here's a longer problem. We have added some binomials, but we start with the common monomial factors. 6 and 22 are even numbers. They're divisible by 2. There's an a in a numerator and an a squared in the lower right denominator, so they have a common factor of a. The 25 and the 45 are divisible by 5. We have a b plus 1 in the upper right numerator and another b plus 1 in the lower left denominator. And some students have confused the a minus 3 and the a plus 3. Once in a while they're confused as opposites, but they are not. And in fact, they are relatively prime, so they can't be crossed out. So what's left in the numerator is a 3, a b, a binomial a minus 3, and a 9. The 3 times 9 goes together to make 27. We bring the b and the a minus 3 down. There's our numerator. And our denominator is 5 times 11 to make 55. Don't forget the a, and then the binomial a plus 3. Once again, while our fraction at the bottom is still quite long, it's shorter and simpler than the original problem. Here's one so long I had to make it in a lower font. So I see the 6 and 4 are both even numbers. The a cubed and the a squared have an a squared in common. The 25 and the 45 have a 5 in common. The b and the b cubed have a b in common. Now I'm going to factor a difference of squares. Then I'm going to factor a trinomial. Then another trinomial. And finally, the last binomial, I just factor out the greatest common monomial factor, which is 2a. I realize that the a in the denominator cancels out the remaining a in the numerator. And then I look at the other monomials, and they don't have anything in common. So now I'm looking at the binomials, and I see a pair of b plus 3s, and then I see a pair of opposites, the a minus 5 in the upper left and the 5 minus a in the lower right. They can be canceled and made into a negative 1 because they're opposites. So now I carefully look at what's left, and in the numerator, 3 times negative 1 times 9 makes negative 27, and then don't forget the b squared, and I have 2 binomials left to place in our numerator, and in the denominator I have a 5 times 2 times another 2 to make 20, and our binomial b plus 2, a very long fraction, but again, much simpler than the original problem. And you may have noticed that all of the canceling has been something in the numerator of the first fraction with something in the denominator of the second fraction, and then perhaps something in the numerator of the second fraction with something in the denominator of the first fraction. So many students notice that the canceling all seems to be diagonally. Well, this will always be the case if the fractions you're given in a multiplication problem are in lowest terms in the first place. But if you happen to be asked to work a multiplication problem where the two fractions are not initially in lowest terms, then you might have to cancel in the numerator and the denominator of the same fraction. And while many times you'll be given multiplication problems where the factors are fractions that are already in lowest terms, once in a while You'll be given fractions that are not in lowest terms, and you can put them in lowest terms first, and then continue working the multiplication problem. When multiplying algebraic fractions, factor all of the numerators and denominators completely, then cross out factors in numerators that have matching factors and denominators. Finally, multiply all of the factors that remain in the numerators and denominators.